Many types of systems can be represented with a causal loop diagram. A causal loop diagram consists of nodes and lines. Each node is a variable. Each line is a relationship between two nodes. Let's take a look at how we would set up MacAD to draw a simple causal loop diagram. We'll start by closing this project and opening a new empty project. We'll give the project a name, and we're going to be using a dictionary document and a state model document. In the state model document, we're going to select the causal loop method. So we'll click OK to generate the documents involved in this project, and we can now open that project. It's been added to our list. So we have our dictionary document, and we have two different windows associated with the STD document, but we're only going to be using the diagram window. So we can open up the document defaults dialog and select the diagram window only, and now our project is set up and ready to draw our causal loop diagram. We'll start our system model by selecting the state tool and creating a variable named deposit. Create a second variable named bank account. And finally, we'll draw a line between those two representing the relationship between deposit and bank account. And since we don't need any name displayed on the diagram, we'll clear the displayed as name and click OK. Let's merge this information into our data dictionary now, and we can go to the dictionary and we'll see that there's now three entries, one for bank account, one for deposit, and one for the relationship between the two. Let's define the variables and equations in our system. We'll select the deposit node, and in the details dialog, we'll give that a value of 100, a minimum of 0, and a maximum of 1,000. And the bank account variable in our details dialog, we'll give it an initial value of 1,000, a minimum of 0, and a maximum of 10,000. And finally, in the equation that really links those two variables, in the details dialog for that, we'll have bank account equal to bank account plus the deposit, and as a second equation, we'll have bank account equals, we use a function called digits that rounds it to dollars and cents, and we want 2 digits following the dot, and so that's our equation. We now have defined these two types of variables and an equation between the line that links those two variables. After drawing a causal loop diagram and defining the variables and equations, you can actually simulate the system. We'll see how that would work by bringing up the details dialog for our relationship line there, and we'll see how the equations we've entered can be translated into a snippet of scripting language. So we're going to now use that script that was just generated for us with the simulation window. And in the simulation window, we'll click the reset button just in case we've previously simulated in results to get rid of those old results. We're going to increment over a series of 10 loops through our equations, starting with an initial value in the deposit and bank account of 100 and 1,000. And we're going to generate the simulation script from our model and increment it through that script 10 times, and then output the results to the file called simulation_output.data. That all occurs when we click the run button. It's happened now, so let's look at the output results, and it's generated the results to a file. We see there was a run count of 1. Here's a series of what the variable deposit looked like for each of those runs, and here's the output of the bank account variable over each of those runs. Now let's do a second run, and in this case let's change the deposit value to 2 $200. So we'll be making a $200 deposit during each run, and we'll run the simulation again, and let's look at the results. Now we see that there are two runs. The first run was a deposit of $100, and that was the result. The second run we did a deposit of $200 each increment, and that was the result. Starting from those initial two variables, deposit and bank account, and the equation between them, we've now expanded the model to include additional variables in relationships. For example, we're doing withdrawals from the bank account each year, and over time we'll have a summation of our accumulated withdrawals and a summation of our accumulated deposits. Our bank account earns interest, so that interest that's earned goes back into our bank account. However, there may be some deduction from the bank account. For example, there may be a service charge. There may be income tax based on the interest earned and the current tax rate, and that will be reducing the bank account. Over time, we can do a summation of the accumulated tax we've paid, the accumulated interest we've earned, and we can now see how these equations, which have all been generated into little snippets of script, can be tied together into a simulation. Using the simulation window, we'll now set some initial values for these variables. For our deposit, we'll set that to $100 a year, and our withdrawal, we'll set that to $50 a year. And if we now build a simulation script and run it through a series of 10 increments, we'll do that. It will put the results into the output file like it did before, but now it will also feed those results into a nicely configured chart that shows each year what the earned interest was, what the deposit was, what the withdrawal was, and what the value of the bank account was at the end of each of those years. It might be interesting to see what would happen to our bank account with different interest rates. For example, let's say we increase from 5% to 7% interest rate and do a run. We'll now see that the value of the bank account changes over time. If we did a second run, or a third run I should say, at 9% interest rate, and we'll see now we have a larger bank account over time with the higher interest rate. We can also look at the same information in other ways. For example, instead of a table format, we could use a line chart where we see the interest rate at 5, 7, and 9%, or as accumulation. Here we're seeing the last run at 9% and how we've accumulated our withdrawals, our deposits, our tax, and our interest over time.